Okay, let's have a look at a more complicated example of specification and code generation. So remember last time we had our installation in a directory here, UML RSTS20, and we've got the models in this directory including the generated code. So that was our previous system. The model file is by default called MM. We can rename that to MM Hello World as our example. Now these model files are just text files. They hold information about the use cases. In this case, that it's just got one constraint, one post condition defining what it does. That's a very minimal model. Let's create a more interesting model of a student and course registration system. So we run the system as before, UML rsts.jar. And here we can create classes. And so we want to create a class called student. And we select where to put it on the diagram, and then you can edit any details here. This is where you would describe something as abstract or as an interface, but in this case we're just going to have it as a normal class. And typically with classes you would add attributes and operations and other things. Attributes are added through this dialog. We might have a student ID for each student, and this is a unique string, and uniqueness is put there so that each string of different students is different. And that's signaled by the annotation that it's an identity attribute. Now we might have ordinary attributes like a name. Again, it's a string, it's not unique in this case. Different students can have the same name. And we can have an attribute age. Age could be an integer or a double representing a number of years. And we can save the model. And also in the system we might want a class that represents modules that the student might take during their course. And again, a module probably would need some unique code to describe the module, to uniquely identify the module. And a module might have a name or a title, again, a string. But that's not unique. So we can save the model. At this point, we've got two classes in our model. But what's interesting is to be able to define relationships between classes, and these in UML terms are called associations. The role 2 indicates the role at the end of the at this end, role 2, at the end where you stop drawing. Role 1 is the end where you started drawing. You don't have to put role 1. Role 1 is optional, but in this case you maybe want to keep track of the students that are on each course. Now here you can set the multiplicity. The multiplicity of this relationship would generally be many, because many students can be on each module, so this end is many, and also many modules might be attended by each student, so this is many, this is many at that end. There's nothing, we don't need to put ordering here. By default these are modifiable, and we can add them. There's various other things that you can do there, but we want the defaults usually. There again, you can save the module. You can edit it to make it more attractive if we want to make that more. And at this point we can again generate code. Let's generate Java 7 just to be a bit different. and we end up with some Java 7 code which represents those classes. For example, the class student with student ID and so on and so on. The modules becomes a hash set, it's not ordered. Also in this code, there are operations to manipulate sets of students and, for example, to look up a module by its ID, because we've got a unique identifier, we can look up modules by ID, same for students as well. Creating a student involves checking that the student doesn't already exist. The student doesn't already exist. If the student does already exist, we would simply return that student. If the student doesn't already exist, then we create a new one and set its features to be default values. And we store that student in the index. So all of this is attended to by automatic operations, set student ID also. If we're going to manipulate the relationship between a student and a module, like adding a link from a student to a module, then we need to add that link in both directions. We add the student to the class list of the module, as well as adding the module to the list of the student, module list to the student. So all of that is done for you automatically. Now, to create global functionality, we create global use cases, and these can be things which manipulate the system as a whole, which are operations on the system as a whole. For example, to register a student, and we can register a student with a given ID, a given name, and a given age. Doesn't have a result, and that becomes an operation which we can then define more details of. Okay, well, I'll go into more details of this little system and how you can run it and change it in the next part of the course.